Hi everyone, am I audible?
Yes, sir.
Yes, you are audible.
Okay, so I'm Pingach. Today I will be taking the session. In the today's session, we will take your doubts regarding activity question of week 9 and practice assignment of week 9. So just give me 2 minutes and then we can start, and then you can start asking your doubts regarding the activity question and practice questions. Okay. And before that, just wait for 2 minutes. Okay. Guys, the screen is visible to you all. Anybody?
Yes, yes.
Okay, so you can start asking your doubts of activity question, practice assignments. Have you gone through the lectures, everyone? Okay, try reacting to the words so that I will know. Even if you don't complete the lecture, you can tell me.
Sir, not complete actually.
Okay, so like, have you tried any activity questions till yet?
No, sir.
So none of you got any doubts regarding week 9? If it's so, we can just start by solving activity questions. Okay, is there, you can react to if you just agree to my points. Like if you guys want me to start solving activity question, like you don't have any doubt.
When will be the revision session for stats one?
uh,
Actually,
revi-
expecting
revi-
today, so
revision session of for quiz 2.
stats one.
Like stats on which week? Like I think already we have some
Quiz.
week of for quiz 2, na? Not
Yes,
today.
sir.
It
Yeah,
will be,
yeah.
yeah, it will be like, when will be your next instructor session? It will be on that day, most probably. For today, it's the activity question and practice questions of week 9. So I think we can start solving the activity questions. If you guys don't
Week
got any
9 graded assignment submit tomorrow, no?
uh week 8 graded assignment.
No, no, week 9.
Week 9 deadline, let's see when
Yeah,
it's
tomorrow is the deadline.
okay. Yeah, tomorrow is the deadline for week 9.
And
Okay, so nobody got any doubt, so I should start solving by myself only. Okay, so just tell me the screen is visible to you or not.
Yes, sir. Visible.
Okay, so the active question 9.1, the very first question we got is, a random variable is a subset of sample space of random experiment, a relation defined on sample space, a real valued function defined on sample space. So it will be a subset defined. I think it's either these two, A or C. Let's check. So what a random variable is? Random variable. I'm not very familiar with Sumo. So just wait a second. Okay. What a random variable is a real valued function defined on the sample space. We have got some, let's say for rolling a dice, in for a rolling a dice experiment, we have got this sample space 1, 2, 3, 4, 5, and 6. And a sample is a random variable is basically a function defined. Let's say the random variable is all those uh, a random variable, let's say we roll two dice. So a random variable, so we can define a random variable as sum of the outcomes. Okay. So these are what a random variable is, a real valued function defined on the sample space. Then after defining a sample space, let me for the second question we have got range of random variable x is the set of all possible values x can take. Let a random variable y be defined as number of tosses until first heads comes on tossing a coin. Then what will be the range? So what is the what here? What is our random variable? Y is defined as number of tosses until first head comes. Okay. So it is so the what is the like minimum value possible? Like we got the head on the very first toss. So the minimum value this random variable can take will be one, and it can goes up to infinity. Like there are we can't have a certainty how much take it will take to get an tail. So this will be the right option. Option C. Okay, guys, try to make the session a little more interactive. You can just uh, say yes or like I got it after the question. It will be helpful for me. Okay. Okay, so here for the third question, what you have got, two cards are drawn simultaneously from a well-shuffled card of 52 cards, deck of 52 cards. Each of the first card carries 10 points and other cards carry same point as its number. Assume ace carries 1 point. Each of 10 cards carry 10 points and other cards carry the same point as its number. Okay, let's X define as the sum of the points of withdrawn cards. What are the value X can take? Okay, so what they are saying, we have got this 52 deck of 52 cards, and in these cards we got these many different cards like 1, 2 up to 10. One is defined as ace, and then three face cards, joker, king, and queen. Now what they're saying, this joker, king, and queen are of 10 points. They carry the weight of 10 points, and then ace carries 1 point weight, and all these carry the point which are written on this, the number which are written on the cards. Okay. So let X be defined as sum of point of withdrawn cards. So defined as the sum of how two cards are drawn at one time. The minimum most value of a card is A, which is 1. And we are drawing two cards. So the minimum value we can take, the X random value X can take is A plus A, that is 1 plus 1,
Two,
which is 2. And the highest value it can take is
20.
if when you take two face cards, either of them, J, K, Q, N plus either of them. Okay, so that will be 10 plus 10, till 20. So it will start from 2 and goes up to 20. Between that, it can take any value. That's the answer. That's the answer for the third question. It was Kishore, na?
Yes, sir.
Okay, yeah. You got it right.
Yes, sir. Got it.
How many outcome will result is x equal to 19? So we have got these options 1 till 10. Then how many outcome will result is in 19? So we have got three card of in 52 cards. We got four subset of card again, in which two are reds, like ace, heart, spades, and clubs, and each got 13 cards in them. So 1 to 10, then three face cards. Now what they're saying, how many outcome will result in 19? So for the one ace, I either we will take jack or 9, and we can take 9 or jack. Then we can take king and 9. Here the face card JK and queen has 10 points, okay, on them. And then we can take queen and 9, or 9 or queen, or 9 or king. So for these 13 cards, there are possibly 1, 2, 3, 4, 5, 6 possible combination. And we have got in total of 1, 2, 3.
The 9 and 9, you can 19.
No,
Okay, sir.
no, it's 19.
So 10 and 9, we can take no.
10 and 9. Yeah, one more combo, 10 and 9. And I think we should even consider
9 and 10.
9 and 10. Yeah, that's was it? But like ace, like a ace, a king of ace plus, okay, it will be much more. Now we can even consider a king of ace, then like we can choose two of them, ace and heart, then a heart,
The king of
then a,
ace. That what is that?
like we got a king card, and every these like we got now we can divide 52 in four subsets: ace,
Sir,
heart,
that will be
sixes.
diamond, no, sir.
Oh, sorry,
Heart.
yeah, okay, yeah, that will diamond. I was wrong here. That is diamond, heart, spades, and clubs. Okay, and for every these subset, we got three face cards in it. So in total, how many face cards we have got? I think this is the wrong approach. Let me clear this. Okay, so how many face cards we have got?
12.
12. Yeah, 12 face cards. And then how many
10.
10? How
4,
many
sir.
10 we have got? 4.
4.
And how many 9 we have got? 4.
4.
Okay, so one possible way is choosing a face card and a 9. And so
The
we have to
face
choose.
card with 9 we should choose, no, sir. And a 9.
Face, that,
Multiplication will come, no, sir.
yeah, that's the same. Like you can put a comma here. Face card and 9. Okay, 12 C1. We got 12 face card, and we can choose one from them into
9C1.
10C1, 10C1. We have got 10, 9. Okay, sorry, 4C1. We have
4C1,
got,
4C1, 4 card
yeah,
of.
4C1. This is case 1. And now this is one way, and we can even do the combination, the permutation matters here. The order is different here. So we have to multiply this to 2, like all this way will fetch, like, uh, like this can be case 1, okay? And this is case 2, you can say.
Yes, sir.
You guys are getting it? So for the case 2 again, this was for case 1. For case 2, we will get 4C1 cross 12C1.
Yes, sir.
And now for case 3, we can choose a 10. We can choose a 10 or a 10 and a 9. And for case 4, we can choose a 9 and a 10. Got it? So in this case, we will get 4C1 into 4C1. Similar for this case, 4C1 into 4C1. Now we have to add all these cases. So let's see. That will be 12.
Into 4.
12 into 4. That will be 48. Then for this is again 48. This is 16. Okay, I think this question, the random variable is defined as the sum, na? So the order doesn't matter. So we have to take two cases only. The two cases will work out.
Yes, sir, because
Yeah, that
taking
like order doesn't matter.
9 is same as 9 and plus, sir.
Yeah,
Sum will be same.
yeah, sum will be same. So in this we got 4C1, which is 16, and now we have to add both cases, case 1 plus case 2. That will be 48 plus 16. So in total we will get
64.
64. Okay.
Yes.
A random variable for the fifth question we have got. A random variable x is defined as the times from now until the next train occurs in the certain city. What is the value x can take? It can take 0 to infinite. Like there will be times, what random variable x is, time, time from now until the next train occurs in a certain city. So what are the values x can take? So it, the rain can come consecutively, it, and then it goes to infinite time. So it's obviously the value x can take is 0 to infinite, and we don't put close bracket on infinite, so we have to put open bracket on infinite. Then the A will be the answer.
Sir, infinite will be when there will be no rain
Yeah,
in
there
that
will be no
particular
rain.
city.
Yeah, in the particular city, after raining, there will be no rain after, or after very long time. Like this. Okay.
Okay.
The coin toss are tossed simultaneously. Let a random variable x be defined as the number of head minus the number of tails resulting from toss of three coins. What are the values that x can take? So the variable we got, the random variable is defined as number of heads minus number of tails what are the values that x can take. So we can, and we are tossing the coin for three, toss of three coins. Okay. So in three, there will be a chance when we get. So basically, we have to, for finding the range, we have to find the minimum value, then a maximum value. So for the minimum, we got, there will be times when there is zero head and three toss.
Three
So
tail.
three tails, sorry. So minus three will be the minimum value of which x can take, and the maximum will be just reverse. It will be,
Three head and zero tail.
so it will be three, and in between it. And now we can take two. And one thing to notice here is we can't, this variable can't take one as its, like two as its value. Because if we get two heads here and one tail, it will eventually lead us to one, or we can reverse the order. Either we'll get one heads and two tails, it will lead us to minus one. But there will be no chance when we will get
Both.
the two as a value of random variable. Okay. So here
Yes,
we,
sir.
so this will be the sample space for the random variable. Got it?
Yes, sir. Got it.
Two cards are withdrawn from a deck of 52 cards, one after other without replacement. A random variable x is defined. X0 if both cards are face cards. X is equal to 1 if exactly one of the card is face card, and 2 if none of them is face card. Basically, for this question, we have to find that probability. We got two face cards. Now we have to find the probability of x is equal to 1. So exactly one card is face card. We have to find probability one face card intersection one one normal card. Yeah. So that will be one face card. We got in total of 12 face card. So 12C1 into, now if we remove this 12 from 52, we'll get 40. Then we have to choose 40 card of one card out of this 40. And in how many total ways we can choose two card out of this 52 card? That will be 52
C2, C2.
C2. So that will be 12 into 40, and down the denominator we will get
52. C2.
52 C2 1326. Let's check if our answer is correct or not. 0.36, we are getting nearly 0.36, 1 and double nine, something like this. So when we approximate it to two digits, we'll get this as one answer, and this is the answer. Okay.
Yes.
This is again one similar question. A small village has 120 female voters and 90 male voters. A sample of 10 voters is chosen. Let a random variable x defined as the number of male voters in the chosen sample. What is the probability that x is equal to 5? What we can interpret from x is equal to 5? X is the random variable defined as the number of male voters in the chosen sample. So basically, we are choosing 10 people, and we need five of
Male
them
voter.
to be men, five of them to be men, and 10 females. Five of them to be male and five female. Okay,
Five him.
five female. So now, in how many ways we can choose five males out of 90,
95.
and in how many ways we can choose five males out of 120 female.
5.
120, choose 5. And in how many ways we can choose 10 peoples out of 120 plus 90,
200.
which is 210.
C10.
210. 210, choose 10. And this should be the answer. Let's match the. So this is what we got, yeah? And this is the answer.
Yes.
The question number 9, an insurance salesman visit up to 3 clients every day, hoping to sell a new policy. He stops for the day once he makes a sale. Each client independently decide whether to buy a policy. 10% client purchased the policy. Let X be the defined as the number of sales he made in a day. Find the value of X is equal to 0. Actually, we have to find probability of X is equal to 0. So an insurance salesman visit up to 3 clients. So then total of X can take most of 0, 1, 2, or 3. He stops once he makes a sales. Okay. Each client independently decide whether to buy a policy. 10% of client purchase the policy. The probability that a client will purchase the policy is 0.1.
1.
Let X be the defined number of sales he made in one day. Find the probability that X is equal to 0. So what is the probability of a client not purchasing the policy? Client not purchasing the policy. That is 1
One.
minus
0.9.
probability that client will buy. So it will be 0.9. Now we have to find P of X is equal to 0. We got 3 client. He will visit 3 client and they independently decide whether to buy a policy or not. So what is the probability that the first client he visit will not buy the policy, will not buy the policy into, basically in this question, what we have to calculate is probability that client 1 intersection client 2 intersection client 3 together not buying the policy, and these 3 are independent events. So the probability that client 1 will not buy the policy will be 0.9 into 0.9. Same for C2 and now for C3. And on multiplying all this, we will get
0.729.
0.729.
729.
And that should, and write the answer up to 3 decimal place. So that will be 729 and it will fall within the range. Okay.
Yes.
For the last second question, a postman has 3 posts to deliver in 3 adjacent houses in the area, but he is not sure that which post belong to which house. He delivers the post randomly. Let a random variable x be defined as the number of house he delivers the right post. What is the number of relevant outcomes for x is equal to 2? Okay, so see, we got 3 houses. And we got 3 posts, and the postman doesn't know which post belong to which house. Now it's saying what is the number of the x variable, x random variable is defined as the number of house he delivers the right post. So he's saying what is the number of relevant outcomes x is equal to 2. When x will take a value of 2, that means the postman deliver 2 posts to where they belong to. So 2 posts the where they belong to. So automatically the third post
Third one.
will get delivered to the house it belongs to. So basically, there will be no such cases when x will take a value 2. It can either take one value, 1 as a value, 0 as a value, or 3.
3.
Okay, so it can't take 2 as one of its value. Because when he delivers 2 posts to the right house, the third one will automatically get delivered to the right house. So 0 will be the answer for this question. For the last question, four students are chosen randomly from a class of 10 boys and 10 girls. A random variable X is defined as the number of girls in chosen students. What will be the cardinality of the set of relevant outcome X is equal to 2? So X is defined as the number of girls chosen in the student. So basically we got in
Two
total of
girls are chosen.
20 students. Now when X will take the value when two girls are chosen, and 8 and how many are we are choosing? Four students are chosen
Four.
randomly and two boys are chosen. In how many ways we can choose that? In 10C2
10C2 into
into 10
10C2.
sets. And they're not asking about the probability, they're asking about the cardinality. So this should be the answer. This, we will do this calculation. 10C2.
2025, sir.
This is the whole calculation.
Yes, sir.
Okay, so 2025 will get the answer. That's the answer. Okay. If they have asked for the probability, we have to divide it by 20C
20C4.
C2, 20C4, yeah. Okay. Now we can move to the next activity. Okay, so in this we will after this 9.2 lecture you will study about continuous, continuous and continuous and discrete random variable.
Sir, excuse me, sir.
Yeah, Madhav.
Sir, I had several questions and several doubts in 9.1.
9.1.
Yes.
Okay, let me go back to that. Activity question 9.1. So in which question, the question number you got doubt in? Madhav.
Yes, sir. Just a second. I'll just open up.
Okay.
Question number 5. Question number 5.
Question 5. Okay, wait. Question 5 in this question.
Yes, sir.
Okay, so
I thought it should be natural numbers, but the answer is 0 to infinity.
it should be now. In hours. So how you thought it should be natural numbers? Basically, you assume that it can be right hours only this 1 hour, 2 hour, 3 hours. Then only it will be like natural numbers. But we can even write 1.5 hours,
In
1
30
point,
minutes, if it start
mm,
raining, we will write
yeah,
0.5.
yeah, or 1.00007 hours. We can li
Oh,
we can
okay.
write it this way, no? So it's will a natural number is basically 1, 2, 3, only this. So that's why it will be 0 to infinity. And we, as a math basic rule, we don't put close bracket on infinity side. So we will be putting this open bracket. So that's why you got your concept
Yeah,
clear.
yes, sir. Yes, sir.
Okay,
Yes, sir.
so
Yes.
what's your next doubt?
It's question number 7.
Question number 7. This question, okay. Okay, what's your doubt in this question?
So, in such questions in which there are multiple things to evaluate at the same time, I just messed up with the calculations and I don't
So
ever get answers.
like first of all, you should have know the demography of cards, 52 cards. Yeah. Like no, like 52 cards are divided into 4 parts.
Yes, sir. Yes, sir. 14 each.
Diamond, then clubs, hearts,
Spades.
and spades.
Hmm.
And 13 each, not 14 each, 13 each. And we got 10 cards. You start from 8 to 10, and then 3 face card. King, queen, and joker. For each of these sets, and what they're asking in this question, if exactly one card is a face card. So in total, we will get 12 face card.
Hmm. Yes, sir.
Now they are saying exactly one face card. So we are picking out 2 cards, and exactly one need to be a face cards. And in how many ways we can do that? 12C, one way, okay?
Hmm.
And then
Yes, sir.
we had 52 cards. Now we have to see how many normal cards we have. Now we can't have one face card here, na? So in
Yes,
total
sir.
now we are left with 40 cards. So we have to choose one card out of these 40 cards. Then only there will be exactly one face card and one normal card, like one card from which will be from 1 to 10. And and
Okay.
now this is the total number of ways you can have one card, one face card, and one normal card. Now, what are the total number of ways you can pick 2 cards out of 52 cards? Basically they are asking for probability. So we have to divide it by total number of possible outcomes. So in 52C two ways, we can choose 2 cards out of 52 cards. And on calculating this, I think we got 0.36, na?
Hmm. Yes, sir.
Okay, so this is how you solve this question. So
And so one more a little bit of I just wanted to see the expansion of this 12C1 and 40C1 and any one of them.
in 12C, that will be 12 factorial by 1 factorial by 12 minus 1 factorial. So you can write 12 as 12 into 11 factorial. 1 factorial is simply 1 factorial. And in down below, we got 11 factorial again. In solving this both will cancel out. So we'll get 12.
Hmm. Okay. Okay, sir.
Okay. Okay. So any more doubts? Uh,
And
And
8.
yeah, Rasmi. Okay. Who was speaking?
she was saying about eighth.
Question. Okay. Question 8. This question. This is again a similar question. In total, we have got 120 females voter and 90 males voter. 120 female and 90 male. So how many total number of voters we have got? 210 voters. And we have to choose 10 people out of them. And the variable x is defined as number of male voters in the chosen sample. Then they're asking what is the probability of x is equal to 5. So when x will take the value 5, when we got out of these voters, we got 5 male voters and 5 female voters. So in how many ways you can choose 5 male voters out of 90 male voters? That will be 90 C5. And in how many ways you can choose 5 female voters out of 120 female voters? That will be 120 choose 5. And in how many ways you can choose 10 people, 10 voters out of these 210 voters? That will be 210 C10. And that will be the answer. It matches the option B, and that's the answer. You got it?
Yes, sir. I have,
Like,
excuse me, sir. I have doubt in 9.2 activity. Question
oh,
number third.
okay, wait.
So before it, can we have a quick glance in ninth question of this activity itself?
Okay, okay. So in the ninth question, a instant salesman visit three clients every day. The salesman visit three clients every day, hoping to sell a new policy. He stops for one for the day once he makes a sales. Okay. Each client independently decide whether to buy a policy or not, and the 10% of the client purchase the policy. That means the probability that a client will purchase client will purchase a policy is 0.1. And now what they're asking, let X be defined as the number of sales he made in one day. So find the value of P equal to P, or probability of X is equal to 0. So X, the random variable we got, is number of policies he sells in one day. And we have to find the probability of P is equal to X is equal to 0. That means he sold no policy on that day. Now, this is the probability of the client buying the policy. But now what we'll do, we will use the complement law and we will find the probability. This is the same as here, okay? The probability that a client will not buy a policy. Client will not buy. So we got this as 0.01. So 0.9 will be the probability that a client will not buy the policy. Now, when he sells no policy on a day, that means the client one haven't bought the policy, and the client 2 haven't bought the policy, and client 3 haven't bought the policy. So the probability, and these three are independent events. So we know from this that C1 intersection C2 intersection C3 will be probability of C1 intersection, into probability of C2 multiplied into probability of C3. What C1? What this probability is, that C1 will not buy the policy. That's 0.9. So that will be 0.9, and similar for PC2, 0.9, and similar for PC3. So we will get something around 729. Okay, and that's the answer. Got it?
So
Madhav,
how this logic? Yes, sir. How this logic works?
this
Because
logic,
yeah, just multiplying the probabilities of all.
these are the independent. These are basically the independent. So you know the conditional probability. The conditional.
Yeah.
Okay, so just let me get some space and erase this. So what is PE given F? What is this? This is
This means probability of E that F given. I mean F is being done. Effect of F that's being done to E.
that. So this probability is basically PE intersection F. E intersection F
Yes,
by
sir.
PF.
Yeah.
Okay. Now what we are saying, that these both are independent events. Okay, these
Yeah.
both are independent events. That what that means, like here,
They are into.
the the occurrence of F will affect E. Like this will not be same as P E given F complement. That F doesn't occur. This will not be same as this. You're getting my point, Madhav?
Yes, sir.
What independent events are basically where PEF PEF is simply equal to, like, this probability PEF is PE. Like the probability of E will not get affected by the occurrence or not occurrence of F. Okay, so
Yes, sir.
this probability is PE only because E and F are independent events. Now this PE is PE intersection F into PF. You're getting it?
Yes, sir.
And when we bring PF on this side, we will get this formula that when E and F are two independent events, then PE intersection F is PE into PF.
Mhm.
And similarly, you can extend this to the probability of three events, E intersection F intersection B. That will be equal to probability of E into probability of
E-
F to probability of G.
Yes, sir.
Okay.
Yes, sir. Got it.
Okay. So next doubt was in activity question 9.2, question 3.
Yeah.
In this question, what you got? There are 10 balls, 10 blue balls, and 5 red balls in a bag. 10 blue and 5 red. A ball is randomly drawn and its color is noted and put it back. That basically means replacement is allowed. Again, a second ball is drawn and its color is noted. Let the random variable x define as x is equal to 1 if both balls are of same color, and x is equal to 0 if both balls are of different colors. So when will take x will take the value 1? The case 1 will be when both are red. Both are red. And case 2 will be when both are blue. Okay. So again, what is the replacement is allowed. Okay. So even if drawn one ball, we put it back. So the probability that we will draw a blue ball is 10 by 15. We got 15 total ball and 10 of them are blue.
Yes, sir.
And then the probability of drawing a red ball is
5 by 15.
5 by 15.
5 by 15. Now in this case, what basically asking, the first ball is red and the second ball is red too. Again, the law of independency, the dependent
10
event
by
is,
15.
so probability of R
5 by
into
15
probability
into
of, that will be 5 by 15 into 5
5
by
by
15.
15.
Then we have to add the second case to it. That will be probability of blue intersection blue. That is PB cross PB. That will 10 by 15 into 10 by 15. Okay, so basically they're not asking the probability. So we should not find the, we are going with probability here. Wait a second. Okay, we have to change the approach. We are solving this for probability. Okay, so we have got 5 red balls and 10 blue balls. In how many ways we can choose? 2 balls out of 5 balls. We got 5 red balls and we need both of them to be 2. So these will be the numbers of ways. I mean, how many drawn? We can choose 2 balls out of
5C2.
5C2, 2 balls out of 5 red balls. And these will be the number of cases we can choose 2 balls out of 10 blue balls. And what this will be? Actually 5 factorial by 2 factorial into 3 factorial. So it will be 10 factorial into 2 factorial into 8 factorial. On calculating, we have to add these two values. Let me solve. Then, if you want, I can explain this once again.
I
Okay,
solved it, but I got wrong answer. I
okay,
solved
let's
it in same way.
let's see. So this is 10, na? This is 10,
Yes, 10 and 45.
10 and 45. So in
45,
case
55.
this 10, sorry, 5C2 is
Excuse me,
10.
sir.
Yeah, wait.
Sir,
Yeah,
but combination doesn't occur on replacement.
combination doesn't have replacement. But wait a second. What 10C2? What is 10C2? 45. Okay, yeah, so it's for this approach we are getting 55. So there's something we are missing. Let's see. What who was saying this? Tanisha.
Sir.
Uh,
Yes, sir.
Okay, so we are saying that. Wait a second. Let me open tab. Yeah, combination is not applied on replacement.
Replacement.
Okay, so I think if we do it this way, we are replacing it. That will be 5C1 into 5C1. Like for the first we are choosing one ball, and then we are putting it back, and then again we are choosing one ball.
Sir, it will be 5C1 into 5C1 because n will be 5 in both the case because we are putting it back in the
Yeah,
bag.
so that's what 5C1 into 5C1. Similarly, 10C1 into 10C1. That will be 5 into 5 plus 10 into 10. 25 plus 100. So 125 will be the answer. And how it's so? What we are mistaking was we are choosing two ball at the same time. But in this question, it is given a ball is randomly drawn and its color is noted and put back in the bag. Again, the second ball. So what they're doing there first to the bag, they're choosing one ball. They are noting its color. Let's say it's red. They're putting it back. Then they are choosing again one ball. So that is how we have to do. We have to first choose one ball. Then again, after putting it back, we have to choose one more ball. So that's why we do it this way rather of doing this 5C2.
Sir, if it's without replacement, then the answer will be that no 55.
Yeah, if it was without replacement and we are choosing two ball at the same time, then it will be like that. Okay.
Okay.
Yes, I got it. So also question number 4.
Okay. An information source generates symbols at random from a four alphabets A, B, C, and D with probability PA equal to 1 by 2, PV equal to 1 by 4, PC equal to PT equal to 1 by 8. A coding scheme encodes these symbols into binary code as follow: A is 0, B is 10, C is 110, and D is 111. The X be a random variable denoting the length of code consisting of one symbol only. Okay, length denoting the length of the code consisting one symbol only, that is the number of binary symbol bits 0 1. What is the probability that X is equal to 3? That X is a random variable denoting the length of the code. Length of the code. What do you mean by this? Length of the code. There coding scheme there are four-letter alphabet. Okay, then
Uh, It's telling number of alphabet used in the code.
number of alphabets, it will be always length of the code. It will always code as consisting of
Symbols at a random from a four-letter alphabet. So we are making code using that four-letter alphabet, and it's asking of length 3.
okay, let me go to the question once again. An information source generates symbol at random from a four-letter alphabet with probability, and a coding scheme encodes this symbol into a binary code as follows. A is decoded as 10, B is decoded as 10, and C is decoded as 110, and D is decoded as 111. B, let X be a random variable denoting the length of the code consisting of one symbol only. That's one symbol only. That is the binary symbols, bits 0 and 1. What is the probability that X is equal to 3? What were you saying, so?
Sir, I got confused after seeing these zeros and ones. Number of binary symbol bits
Yeah,
zeros and one.
this is a little bit confusing. The length of the code consists. Creating the X is the length. Okay, just wait for 2 minutes. I will be back. Okay, just
Okay.
let me see what is length of the code.
I think it is pick one out of four. That's why it's 1/4.
Okay, am I audible?
Yes.
Okay, so what they mean by this, reducing the length of code. Okay, so this source code generator first generate a code out of this four letters, and then this decode encoder encode these symbols into binary codes. They first of all they made a symbol out of these four letters, and then we encode these symbols into binary codes. And what they are saying by denoting the length of the code is, see, the length of this code, they're encoding it into. This is of one length, this is of length 2, this is of length 3, and this is of length 3. So what they in question they're asking, code consisting of only one symbol. So it can, they are saying they consist of only one symbol, like only one of them. And then what is the number of binary symbols? What is probability of x is equal to 3? Like they're choosing only one of these letters, and then then the random variable they define is the length of the code they're encoding it into. Like they're encoding a into 0, b into 10, and c into 110, and d into 111. And basically you can see here they are encoding c as a length of 3-digit code, and similarly for d, the probability that x will be equal to 3, that will either they will choose c or either they will choose d. So and it is given to us that they choose the source generator choose pc and pd with a probability of 1 by 8 plus 1 by 8. That would be then 2 by 8. That will be 1 by 4. Let's check the answer. And you guys got it, or should I explain this one again? Once again?
Sir,
Got it, sir.
Sorry?
sir, repeat once more.
Just let me clear the screen first. Okay, so in this question, what they are asking, a information source generator symbol generates a information source generator symbol at random from 4-letter alphabet. There's some information source generator which generate a symbol out of these 4 alphabets with probability of like that it will choose A for the symbol for generating that symbol is 1 by 2, and it will choose B for generating that symbol is 1 by 4, and it will choose C for the C or D. The probability of it will choose C or it will choose D is equal to 1 by 8. Now what the question is saying, let X be the, and before that, a coding schema encode the symbol. First of all, they generate a symbol, let's say something like this. Okay, they generate the symbol, and then one encode this into binary language. You know now what a binary code is? Basically, a code of such kind, it comprises of only one or zero, and every number is represented only in this way only, 0 and 1, using zeros and one. So the encoder encode A as 0, B as 10, and C as 110, and D as 111. Now what they're saying, X with the random variable denoting the length of the code. Length, this is the code they are encoding into. So length of the code for A is 1, and the length of the code for B is 2, and the length of the code for C is 3. Similarly for D is 3. Now they are saying consist of only one symbol. Like here we choose two symbol A and B, but the for this case we are choosing only one symbol, either A, either B, or C, or D. And X is defined as the length of the code we encode that symbol into. Then they're asking what is the probability for X is equal to 3. So when will be the length of the code will be 3? When either it will choose C as one of the symbols, C or D. Either it will choose C.
Yeah, sir, I got the point. Thank you, sir.
Okay,
You
either
can
it will
go ahead.
choose C or D. So the probability for C or D is 1 by 8. So what we do, we basically add the probability of this. Basically, we, in more formal way, we make two cases that it will choose C, and the probability for that will be 1 by 8, and it will choose the probability for this will be 1 by 8, and we add both of these cases and we'll get 1 by 4. Okay. So any further doubts?
No, sir.
Anyone else?
No, sir.
We're in activity 9.3.
Activity 9.3. Okay, wait. Again, yeah. Which question?
Question number 2. Yes, question number 2.
Question number 2, what we have got? Let a rod of length 10 centimeter be broken into two parts. Got a length of 10 centimeter can be
Sorry,
broke.
sorry. Yeah, this I've got this one. Sorry.
Okay, so any further doubts?
So this third one.
Third.
This really blurs the line between continuous and discrete for me. I just wanted the clarification between these two. By
Let's
this
see.
question third.
Which of the following is a discrete random variable? Length of phone call. Let's see what they are answering. What's the answer for this? The length of phone call.
Continuous, sir.
Continuous, it can go like it can 10 and 23 minutes, 1 hour, 1 hour 20 minutes and 3 seconds, 30 seconds. So it will be obviously it will be continuous. Number of customers visiting every hour in the shop. This will be
So
discrete.
discrete customer
Yeah,
cannot be.
yeah. You cannot have a half customer or something like this. 1.75 customers. So this is again discrete. So one of this is correct. Amount of milk produced yearly by a particular cow. So this will be continuous. A cow can produce let's say 220 liter, then 220.020 liters. So 110.0001 liters. So it is continuous again. Number of accidents taking place every hour. So this will be discrete. Can't have 1.5 accident.
Yes.
Either will be 10. It will be a like integer value, or moreover, it will be a natural number. Travel time from your home to the office. Again,
Continuous.
it is a time, so it will be continuous. Time interval between two successive goals in a football match. Again, this is time. This will be continuous only. Like two successive goals. So it can be anything 10.30, so 10 and 30 minutes, 10 minutes and 30 seconds like this. Proportion of people who cast their vote in favor of national party. Okay, see, if it was number of people who cast their vote in favor of national party, what they're asking proportional. What proportion is number of votes they cast to the national party by total number of votes. So this can lie between an interval and can take a decimal value. So again, this is not a discrete. I think this is where you got confused. Yeah, Madhav?
Yes, sir.
Everyone
Yes, I
got,
got it.
Mm.
Got
everyone
it,
got
sir. Just we have to see for the natural numbers where the natural number lies.
no, it's not a natural number, but thing is that it can take any interval between an interval. It can take any interval between interval. Okay, and the discrete will take a discrete interval. Okay, it's not we
So
have to
can you explain last one?
this one. Okay, so
Yeah,
what
yes.
what proportion is basically? Basically, proportion is again the fraction that they're asking voters say who cast their votes in the favor of national party. We got a national party as one of the option in a election, and let's say 30 voters cast their vote in favor of national party, and in total we have got, let's say 30, let's say 51 total votes. There is some other party, let's say Y party, and the 20 votes goes to them, and one voted for Nota, none of the above. So Nota, like this, okay. So they are asking for proportion. What proportion is? You take the total number of votes which they cast in the favor of national party and the total number of votes which get casted. So you will divide this by 15, and this can take any value between some kind of interval. This can go to infinitely small. This proportion can go to something like 2.0, 2.0000001, like this. Okay, so this is a continuous variable. It is not taking it can take a discrete value, but there are high chances it will take a decimal or something, this kind of values. Okay,
Yes,
got
sir.
it?
Got it. Yeah, yes, sir. Got
Like if there
Yes,
was,
sir.
if the option was like this, number of people who cast their vote in the favor of national party, that will be a discrete only. Can't have like two and a half people voted to this party.
Yes, yes, sir.
Okay, so any further doubt?
It's the fourth one.
So I have a doubt in 9.2 activity question number
Okay.
second.
Okay, after doing this, we will go to that question. Okay. A random variable x is defined as the length of hypotenuse of right angle triangle whose other two sides are determined by roll of two six-sided dice. Choose the correct option. Number of values x can take is 36. X is defined as the length of hypotenuse. So basically, we have got a right angle triangle and we have got two dice. And after rolling these two dice, whatever we got, let's say for one, we got 1 and 6. So this is treated as the two other side of the right angle triangle, and then the x is the length of the hypotenuse. And we know the Pythagoras rule, which is that A, B, and C. So AC is the hypotenuse, and that AC is the hypotenuse, and the length for this will be AB square plus BC square. And this is a continuous variable. There's not a fixed number of values it can take. It can take infinite number of values. It's a continuous variable. It's a discrete, sorry.
That's the problem. That's I got.
1 plus 6 under root, that will be 1 gets to 1, then 36. That will be root 37, and that will be some decimal values. It's a discrete variable. Okay. Okay, I got it. Here's the trick. Like the last question from as I was saying, just because a variable is taking a decimal value, just because the variable is taking a decimal value, like in this case, it is taking a decimal value like this. Okay, that doesn't mean it's a continuous variable. Why so? What a basically a discrete variable is, if you want a definition like this, it can take there's a fixed number of values it can take.
Countable number of
Yeah,
values.
countable number of values it can take, and whereas continuous variable it can take infinite number of values between an interval. Like let's say between 1 and 5, it can take any value, and there will be infinite number of points between this. So the continuous variable can take infinite number of uh, values. Now here we have got this question framed as two dice is rolled. So in how many ways, like how many possible outcome tuples we will get from after rolling two dice? 1, 1, 1, 2, till 6, total of 36
Yes, sir.
outcomes will be, in total
Yes, sir.
36 outcomes you'll get. But now,
Yes.
and so basically and now you can say like 1, 2 or 2, 1 is 1, 2 or 2, 1 is same. We have to rule out this because we are doing calculation like this. 1 square plus 2 square. This will be similar to 2 square plus 1 square under root. So we have ruled out this values, and that will be 1, 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, then 1 and 6. Then for we have to rule out 2, 1. We can go to 2, 2, 2, 3,
30 will come, sir.
2, 4. No, it will less than that. 2, 5, then 2, 6. Now we have to rule out 2 and 3 and 3 and 1. So we will start with 3, 3, 3, 4, 3, 5, 3 and 6. Now we have to rule out 1 and 4, 2 and 4, and 3 and 4. So 4, 4, 4, 5, 4, 6. For 5, we have to start with 5, 5, and 5, 6, and then 6 and 6. Then total will get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 tuples. And this will, like, although this will lead you to a, like, this will lead you to a decimal value. But the what continuous and discrete variable is, the continuous variable is not like this, that it will take a decimal value, but it can take the infinite number of values can take within one interval. Like as I explained here, there will be millions of points, billions, infinitely many points which will lie between these 2 points. So continuous variable, if we define a continuous variable which can take a value from 1 to 5, there will be infinite possibility for the continuous variable to take. But for discrete variable here, even though we are getting a decimal values, there will be only certain number of values it can take. And that will be 21. 21 possible values it can take. That's why it's a discrete value. And the number of values x can take is 21. Got it? This is one good question.
Yes,
It
sir.
will just
Yes,
because
sir, got it.
just because the number is taking a decimal value, that doesn't mean that it is a continuous value. Okay.
Yes, sir. Got it.
Second, option number first. I think option number first is also correct.
Option number first is not correct because
Means I
what
have
is
a
what is random variable we are here? Length of
no, no,
hypotenuse?
in question number second.
Option number second.
In question number second.
Okay,
No,
okay.
in question number second, option number first.
Okay, just wait. Let me switch to the question number second first. Question number second.
Yeah, second.
The rod of length 10 centimeter is broken into two parts that act with the
Yes,
relative
it
length of
can be
smaller part.
also, no?
Sorry.
Means
No, see
can
here.
be
Here
is
we have here we have a rod of 10 centimeter, and we need to break it into two parts. Okay. Now you can do it in infinite way. Like if you want, basically we got 0 to 10 this interval.
means it can be continuous. It can also be discrete.
No, no, it cannot be discrete here. Cannot, like it cannot be discrete simply because it will take an infinite number of values. You can get a number like this, 0.00000, infinitely small number. And basically, in the last question, what we got, the sample space is fixed basically. Got a fixed sample space that consists of 21 outcomes. But in this question, they're saying the 10 centimeter rod is being broken into two parts. and it's up to you how you're going to broke it. You can broke it into any choice of your length. So basically, it can take any length between 1 to 10. The two parts can take any length from 1 to 10. Any length. That from any length I am saying on the number line, can any point can be the value for the random variable. This random variable, any point can be the random variable for this. Not actually, it will be for the smaller part. So smaller part will be, I think, can take any value from 0 to 5. Any value. Like there will be infinite number of values that this variable is going to take. You getting my point? It was Anu, no?
Yeah, yes.
So you're getting my point, or you're getting confused?
Sir, it should not take 5, right? Because if it will take 5, then both will be equal. And it's telling H
So
denote the length of smaller part.
there should be an open interval, and it should be flow. Again, here is an open interval. Getting it can't take value 0 and it can't take value 5. With 0,
Yes, sir.
you haven't broken the length and the rod into two parts. So it's an open interval here on 0 and on 5. Okay. Okay. So Anu, do you got it, or
Yes, sir, I got it.
okay? So any further doubt?
No, sir.
Anyone else?
Question activity 9.4, question number 1.
Activity 9.4. Activity 90.4, question number 1. This question.
Yeah, yes, sir. Yes, sir.
In this question, like when you read about probability mass function, there's these two properties you must keep in mind. First, that probability of any value of x should be greater than or equal to 0. This is one probability. This is one property. And one property is summation of I is equal to like summation of all probability. Like let's say we have got here we have got 5 into that. So summation of 1 to 5 of these probability should sum up to 1. This summation should be equal to 1. So here, what we have to do, we have to find the probability of x is equal to 5, but it is given us with some kind of variable value. So now we have to first find the value of t. What we will do, we will add 0 plus t by 2 plus 4t square plus 3t by 2, and this should be equal to 1 according to this law. Now you have to solve this quadratic equation. So it will be 2 here, then 2t plus 4t square plus 6t is equal to 1. Then it will be 9t plus 4t square is equal to 2. 9t plus 4t square minus 2 is equal to 0. On solving, you will get some value for t. Let's solve this quadratic equation.
Hello.
Okay, sorry, wait. So these are two values you will get, plus 10, 103 by 8 and minus 9. So you have to rule out this value because it will obviously these are negative values, and probability of any well, it can not be 0. It can be 0, but it cannot be negative. So you have to take this value, calculate this, and put this into t, and then you will get t. So most probably we are getting 0.02, 0.20 as our t. Then 3 into 0.2 by 2, that will be 0.1. That will be 3 by 10, I guess, something like that. Not matching that. Okay, somebody was saying something.
Got it.
Again, there's some calculation mistake, but this is how you have to do. This is how you have to do. You have to add all this and equate this to 1, then you will get two values for t. This will fetch your quadratic equation. You will get two values for t. One will rule out because that will be negative, and according to the first law, it, we can't take that value. And one will be positive. You have to put that value into this, and you will eventually get the probability of x equal to 5. Okay.
Sir,
Yes, sir.
but on solving, I got no rational value.
It need not to be a rational value. Just wait. Let me solve this. Okay. 0 plus t plus t by 2 plus 4t square plus 3t by 2. We are getting, okay, I did the calculation mistake here. I didn't multiply 2 here. Okay, so that will be 2t plus t plus 8t square plus 6t equal to 1. Then this 2 will, these 3 will get together and it will be 9t plus 8t square equal to 2. So 8t square minus 90, sorry, plus 90 minus 2 is equal to 0. Now we have to find out the value for t. Plus 9 t. Now it's fine. And now it's fine. The voice is clear enough.
Yes,
Yes,
sir,
sir.
it's clear.
Okay, so for this we will get two value minus 9 plus root 145 by 16 and minus 9 minus 145 by 16. Obviously this will be a negative value, so we will rule out this. Now we have to calculate this value. This will be equal to 0.1901. Now 3 into 0.1901 by 2. Let's calculate this value. 3 into 0.1901 divided by 2. That is 0.28515. It is equal to 0.25. It is 0.75. It is 0.375. It's 0.125. So I think this should match. Let's see. Or again, we are doing some
Excuse me, sir.
Okay, wait. Yeah.
Sir, how you got 60?
How I got 60 in this question?
Yes, sir, in this question.
Wait a second. 16 here. Talking about this question. Whoever this
2t
was.
plus t. Yes, here, sir, 2t plus t plus 8t square plus 60.
Okay, yeah, there's again I made the calculation mistake. It's will be 3t only. So that will be 5t. With 5 and 60. Yeah. That will be 8 square plus 60 plus minus 2, sorry. So I think we are getting 0.2 as our right value. One is minus 1 and one is 0.25. Then you put it into this 0.25 by 2. Let's see if we are getting the answer. 3 into 0.25 divided by 2. Okay, yeah. So it will be 0.375. There. So we got the procedure, na? Just make sure not make the calculation mistake as I do. So the procedure is add all this value and equate this to 1. You will get a value for t. One will be negative, one will be positive. Choose the positive one, put this back into this 3t by 2, and you will get this as your answer. Okay, got it, everyone?
Yes, sir, got it.
Okay, so any further doubts?
No, sir.
Yes, sir.
So go
Sir,
ahead.
on solving roots, I got non-real roots.
On solving, you got non-real root, so you are doing some calculation mistake. Because I just solve it in front of you, and we are getting the right values. So you must have getting some non-real roots. What do you mean? Like, you're getting imaginary roots. You must have done some calculation mistakes only. It is not possible. Try going to the question once again.
Okay, sir.
Okay,
Thank you, sir.
no problem. So any further doubts, anyone?
No, sir.
Okay, nobody else got any doubts?
Sir, can I ask a doubt in week 8?
Week 8, okay, go
If
ahead. Let's see.
anybody doesn't has any doubt in week 9.
Uh, Go ahead, ask about week 8, but we'll not take much of the week 8 doubts, but still, let's take a few.
Sir,
Sir,
I have a doubt in 9.2 activity question number 2.
9.2 activity question number 2. 9.2 activity question number 2. This question?
Yes, sir.
Okay, let's go through it. After that, Kishore, we will go through your doubt. Okay.
okay, sir.
A shopkeeper is interested in knowing that the number of customers entering the shop every hour in a day, the total sales of every hour of the day. Let X be the number of customers entering the shop every hour and Y be the time interval, the arrival between two customers. Choose the correct options. So, number of customer obviously can take value in n. X can take only natural numbers. Cannot be this. Like you will not get some 1.5 customers or 17.5 customers in an hour. So X can take this value and Y be the time between arrival of two customers. So Y is a continuous variable. This time basically the difference between difference of time between the arrival of two customers can be like this: 17 hours, 10 minutes, 2 seconds. So so it is a continuous variable. Y is a continuous variable, and X can take only natural numbers or zero. Like zero is not included in natural number. So that's why it's saying that and union zero. Natural numbers union zero. So these two are the correct options. Got it? Let's
Yes,
check.
sir.
Is that right? Let's check it. These are the correct options. Okay, so Kishore, was your in which question you have doubt of week 8?
Sir, week 8 graded question number 2, sir.
Week 8 graded. Let's try solving this. A and B predict outcomes of cricket match and their chances of predicting runs scored by a specific batsman currently independent of each other if the probability of the predicting the same wrong score is 6 to A and B predict outcomes of cricket match and their chances of predicting run scored by a specific batsman correctly is this. So the probability that A will do a correct prediction is 2 by 3 and the probability that B will do a correct prediction is 2 by 5. If the probability that them practicing the same wrong score is basically B A complement intersection B complement, they both are wrong.
Yes.
Given that they predicted the same score, find the probability that their answer is correct. So basically they're asking A intersection B. So we have got P, na, De Morgan's law. What
Yes,
will
sir.
be, this is A and this is B. This is A complement. Okay. And this is B complement. So intersection will be, basically this is what, this is given, this is A union B. It will be equal to A union B. You can see it here. Let me draw it again. This is A. This is this this event is A and all these are A complement. Now this is B and this all lines are A complement. You can see
Sir,
outside
A
this area,
union B whole complement will be the intersection, no?
this uh, yeah, area which we got intersection
Yes, sir. A union B whole complement.
A union B whole complement. Yeah.
Yes.
So the probability of P A union B will be 1 minus probability of A union B
Union
whole
B
complement.
complement. Yes.
That will be 1 minus 6, 207. That will be 201 by 207.
Yes, sir.
We know PA, we know PB, we know A union B, and we have to calculate P intersection B. That's simple.
Yes, sir. Got it.
So any further doubts, guys?
Yeah,
Please
sir.
solve the question number 2.
Question number 2, active like this.
This question is yes.
So we got 201 by 207 as PA union B. PA is 2 by 3. PB is 2 by 5. We have to calculate. Then we got this formula is equal to PA plus PB plus PA, I'm sorry, minus PA intersection B. We go on. So this will be equal to PA intersection B equal to PA plus PB minus PA union B.
Union B.
2 by 3 plus 2 by 5 minus 201 by 207. In the down below, we'll get 15. This 15. This, that will 10. 6. Then 201 by 207. This will be 16 by 15 if I'm not calculating it wrong. Minus 201 by 207. It is 207 into 15. That is 3105. Then 16 into that will be 3126 minus 3015. 201 by 3105. So 8.
Sir, 3216, it will come 3312, no, sir?
Okay. So
3312.
wait a second. 207, 207 into 16. Okay. It will be 3312. Then on subtracting, we'll get 297.
Yes, sir.
Then on solving, get 297. Eleven by 115 kind of thing. That's not the same. Okay, let's say we are doing some calculation mistake. Let's do it again. Just wait a second. Okay, so where are we? So we got A and B predicting right as P A as 2 by 3 and P B as 2 by 5. With the probability of them predicting the same wrong answer is 6207. Given that they predicted the same score, find the probability that their answer is correct. Intersection B complement is this. Then this will equal to P A union B complement. So 1 minus P A union B complement is probability of A union B 1 minus 6 by 207. That will be 201 by 207. Then we are getting PA union B equal to PA plus PB minus PA intersection B. So PA intersection B, that's what being asked in the question. Two by 3 plus 2 by 5 minus 201 by 207.
Yes, sir. Yes, sir.
2 by 3, 3 by 5. This will get 19 by 15. Then 19 by 15, 201 by 207. Second coming as 34 by 115. Either we're doing something wrong or
Sir, are we doing correctly? Because they are independent of each other. So intersection, we cannot use
okay,
this formula, right?
independent of each other, but I think there is the base
Hello.
given here.
Excuse me, sir.
Yeah,
A and B predictor 2 by 3 and 2 by 5 just like multiply, and the 4 by 15s and the
you're
8s of
saying 2 by
627.
3 into 2 by 5, just multiply to find the intersection. That will be 15 by
4 by 15.
15. That's the answer.
Then the subtracts in 6 by 27. Then answer fine. 4 by 15 and plus 6 by 207. Then 828 plus 90 upon 229. Then the final 918 upon 207.
No, okay, even in getting us the value. So, like, why we are doing this? This is the
Calculate the probability A and B, no, predict the same correct score. The since A and B independent probability, both are the predicted score correct scores. So the 2 by 3 and multiply 2 by 5. Then the 4 by 15. Step 2.
multiply this because these both are independent events to
Yeah,
fill
yeah,
the
of course,
question.
independent
But
probability.
we have to find PA intersection V. So if they're independent, we are doing it multiplying. But why we are
And then
subtracting them?
given the probability A and B predicting the same wrong process 627 207,
Okay,
and this is the sum of the
A and
probability.
A and B, this intersection PA intersection V will be those probability that they will predict the same score. PA cross PB, they are predicting the same score. That's 4 by 15 on multiplying these two. And now we have to subtract when they get wrong. Some same wrong score.
Aided, not subtracted.
We are adding this.
Yes,
And why so?
this is the sum of probability for step 2 according since is the independent the probability both are predicted correct scores. And the given that your
I am getting
probability A and
confused
B.
with this question. But today, let's leave this question. You can ask this question in the next class. Like, I don't want to confuse you more. Let's leave for this question as of now. There's really something I'm missing. So we can see this question in the next class. Okay, any week 9 related doubt?
No, sir.
Anyone else?
No, sir.
Okay, so I think we can wrap up the session as of today. Thank you for making the session interactive session. The last question we got left is 8. What was the question? Grade assignment? 8.
Sir, graded assignment 8, question number 2.
And who was trying to help me? Uh, uh, like, who was giving us the solution?
I think Saurav, I don't know the name
Yeah,
correctly.
Saurav.
Yes, sir. Yes, sir.
Sort of. So sort of.
Yes, sir.
Okay, sort of. Like I maybe know the solution, but I have got confused, so that's why I'm not able to like got it. So as of now, we are leaving this question. Thank you for like helping me. Okay, but
Okay,
in the
sir.
next session we can see this. In next session you can ask this question. Whoever will be taking the session will clear that out. Okay.
Okay,
Sir,
sir.
Yeah.
sir, there will be any doubt session regarding quiz 2 specifically,
Doubt session regarding quiz two.
means
Maybe
any open session If any doubt from week 5 to week 8.
There can be one such session, but I have no idea about that as of now. So I can't like give you can't clear you something like give you
Because in
certain.
week 8, sir, I have means two more question doubts, so I have to ask.
Okay, so like, as of now, I have no idea about this. So
Revision
maybe
and PYQ sessions. There will be.
we have PI, if you have a PIQ session, you can ask those questions out there. But as of now, right now, I don't have any clue regarding that. So
Okay, sir.
okay, so I
Thank you for.
thank you all too, and let's I will see you in the next session. Okay,
Thank you, sir.
thank
Thank
you.
you, sir.
Thank you, sir.
Thank you.